Hey guys, I'm here with an update on the status of our system. Let's just summarize what we have here. This is what we call our protected loads panel. I also call it our off-grid panel. Essentially, everything that's on here is either a source or load. So this is where we have connected our new Sunny Islands, which are right here. And these will, once we get our batteries, these will feed the system. And then the other source is the solar, which again is the SMA Sunnyboy. And sorry, I in the last videos I have a hard time with all their names, Sunnyboy, Sunny Island. But again, so these are our sources. So this is a 60 amp breaker that we're using, 240 volt split phase, line 1, line 2. Going to the control protected loads panel, we have the solar, which I showed you over there. We also have trailers outside, so we have source A from trailer 1 and 2. So it's not two trailers, it's one trailer. Those trailers, those DC solar trailers, have 50 amp outputs and they're wired in parallel to each other. We just use both of them to try to reduce the current on any given pair of conductors. So that's why you have two sources here. I have a car charger, which is down here, which is a car load. AC load, AC is air conditioner, abbreviated. So that goes to that box that I showed in the previous video, which is a 60 amp switch box for the AC. So we can switch it on or off. We have two utility panels here. We have one in the same closet that the load panel for the AC is, and we have another one which we have called West Panel due to its orientation in our building. Let me just show you those real quick. I'll show you what the AC loads panel is, utility panel, West load panel. Okay, so this is the utility room load panel. And essentially what this does, as explained before, is it's Reliance ProTran, which has either the grid as a source or the solar as a source. And with these individual switches, these are connected to the individual given loads, which are labeled here, such as a water heater, some receptacles, lights outside, conference room lights, office receptacle, conference room receptacle, alarm system, lobby, vacuum, warehouse lights. And so that's what happens is this is the final connection to those given loads. The breakers you see here feed this given breaker, and then based on the switch setting, it's either sending the grid power to that load or it's sending what's coming from the solar to the load. And the solar is coming from that protected loads panel that I just showed you. And then this is the larger switch box for air conditioner, where you can have it on the utility, which is again the grid, or when you switch it on to the left, you have the what they say is generator, but in our case it's a solar system. Again, that's connected to the protected loads panel. Then we have the other switch box over here, which is what we call the West utility panel. And you can see we did a better job labeling everything here, but same situation where this is connected to the load and you're switching between the given source, whether it's the utility or the solar system, up and down. I wanted to show you this. This is SMA's video on YouTube that goes over these connections, and essentially they call these connections AC1 and AC2. So AC1 is what, when we talk about the protected loads panel, that's the side of the Sunny Island that's connected to that off-grid panel that I showed you. AC2 is what's hooked up to either the grid or the generator. In our case, we have AC2 connected to a generator. And I'm going to go show you these connections. Now you have DC positive, DC negative. Those are what are connected to the battery that we're still waiting to get. But we do have them all connected to the bus bars. Okay, so here's our Sunny Islands now wired up. I'll go through these connections. I just showed you that these are the DC inputs. Okay, so This is the slave unit, this is the master unit. These DC inputs come down and they get connected to these bus bars. So this is the negative bus bar. So you can see this connection is going on the negative terminal up to the inverter, and then the other negative is here, and it runs back up to the slave inverter. These positives come down, go to the bus bar as you see here, and then the second positive on the master comes down again, goes over, connects right here to the bus bar. So that's your outputs from this bus bar, and then these two inverters therefore are connected in parallel. Now the source, here's the source from the battery that's going to be on the left side, and you can see we've already put Anderson connectors on it. That these are called SP175s. That's what they say comes on those BigBattery Kong Elites. We've also integrated the Sunny Island temperature sensor, and we'll probably hot glue that or somehow affix it to the battery just to get a signal. The same thing exists on this side where we have the SP175 again for the right battery. The battery's going to be on the right side. Let's look at the negative connections from the battery. These two are coming together, tying into to the battery minus of the shunt, so we could read the current using the Victron. This allows us to either Bluetooth connect to it, or as I will show you later, we have this connected to the we can have this feeding data to a Rasberry Pi that will log it and send it to their Victron's VRM portal. Very useful for remote data logging. So that's what we have set up right now. This is a custom bus bar we made. We water jet cut this. I'll show you the water jet in a bit. So we did that so we can have, it's of the same thickness as the main bus bar. This should easily handle 500 plus amps going to the common bus bar. You see that we have two leads here that are going, and these are what are feeding the current signal into the master Sunny Island. So you can see that it's got positive and negative, and we followed the manual. The negative connection should be on the side that goes to the battery side, and the positive connection is the opposite side. And so I don't know if you can see the silk screening here, but there is a positive and negative notation on the silk screening of the board. So that's what we followed. In terms of, this is the battery temperature sensor. So this is what you see. We gave ourselves a lot of extra length. Came down here, so if we have to go further in, we'll just pull it through. So the negatives are crimped and heat shrunk onto terminals. One item that I'm probably going to change is during the calibration process, you have to remove one of the leads and short them to the other for the current sensor. So this is going to be difficult because we're going to be disconnecting the entire battery's connection the way we have it. So we're probably going to drill and tap this copper bus bar to make this lead just come here, so we can unscrew it and do that shorting procedure on the calibration cycle. Okay, so other items are, that's all the DC side that we showed you. Here's also the positive. The main positives are coming. We decided to use these big lugs on the side to introduce the power to the system. Let's go over the AC portion of this connection. So this is what they call the AC1 side. This is what goes to the protected load panel. So because we're using this in a 2 inverter configuration, we're using it to create 240 volt split phase. So this inverter we're making L1. So this is L1, and this is its neutral. This is the other inverter. This is going to be L2, and it's neutral. And those come via this conduit here back to, they come in here, they go up, and they get into this protected loads panel, and they feed this breaker here. The neutrals go to the neutral bus bar that's in the protected load panel box, and they are all tied together. We also put a ground bar in this wiring trough, and so that has the source from the protected loads panel, and it also grounds to everything. So even the grounding bushes are present everywhere to make sure that you ground the conduit. Same thing on every location. Now going to the AC2 side, which is the generator side, or it could be the grid side. These are the connections here. We've used, this is the one on the left, so this is L2. Okay, that goes to L2 of the generator itself directly. These are the neutrals, so one of the neutrals goes to the generator directly, and then we've used this post to allow us to run that neutral connection to the main inverter, the master inverter. So that's the neutral for that, and then this is L1, and this goes straight to the generator. So those are the general connections that exist here for the AC and DC, and also what's left to do is we need to put the control cables that go between the units, and these really are just an Ethernet cable that is has a grounding shield. So I ordered one from Amazon, and I'll get that in. That'll route through the wiring trough and then back up to here. And then the other connection is for the RS-45 for the Data Manager M, which I will make. So we cleaned this up, by the way, the control backs for the Data Manager M. You can see we still have excess wire because it came from the trailers outside. This will all get reduced to just the bare minimum. So what we did was we put a power strip in here. This has both USB and AC. This just wires to a 15 amp breaker coming from the protected loads panel. So this I showed you before, but we have extra room. We're going to use that for probably getting a E-gauge monitoring system, and with that I will monitor the solar. I'll monitor the input from these two units. So these would essentially act as a source, just like the grid would in that setup. And then I'll put a current clamp on the solar, so I'll know the solar production, I'll know what's coming from the source, and then I'll put some on the loads as well, individual loads. But just the math from this, you can figure out what the load is, because you know it's the solar plus or minus what's coming from these equals the load, right? So that math you can do in the E-gauge, and you'll know the load real time, the total load. But then you could also put current clamps on the individual loads here, and so you'll know what individually some of these sub panels are doing, and that'll give you a good idea of what's going on. But you probably don't have to do all of the loads. You could just probably do a couple of them, so then you could do math to get the others as well, right? So if you know that, if you figured out what the load is in general, then if you have at least all but one of these with current clamps, you could figure out the last one via math, and that way you save a little bit on cost, not having to buy excess number of current clamps. So we're excited. We're getting ready for this. As you can see, we've got the wires ready for the battery to come in, and we'll go from there. We'll finish up the remaining items required for this install, which are the control cables, like I said, and clean up in here. But then we're going to move forward with this connection. I'd like to start making other videos which is going to show you the data that comes from this and the data that comes from this and the VRM portal, so that you guys can decide if those are things that you might implement with your system. Obviously this is specific to this SMA product line, but the Victron is kind of interesting. You might be able to adapt this to any system you have, or at least to systems that you utilize, let's say a Victron Shunt or a Victron DC charge controller, etc. I'll show you how some of those things work. Okay guys, talk to you in the next video. Bye. Let this go to on the left, rocking, slightly moving.